substitution and elimination again before we get into some more nuanced details, just to help you gain perspective on what it is we're doing and what we have to be considering, right? So sort of forest for the trees, right? We want to look at a couple trees here to help us to appreciate the forest. So let's look. You recall that this is an SN2 reaction, right? Let me go a little bit thicker on that. Make that a little easier to see. We recall that this is an SN2 reaction, right? Where we've got a nucleophile which attacks a vulnerable carbon, oftentimes has a partial positive on it. A leaving group oftentimes has a partial negative on it. At the same time the nucleophile is coming in, the leaving group is leaving, and this is called concerted. Right? Okay. And so the product of this is nucleophile and inversion of symmetry, right? Where if this is atom 1, this is also atom 1, right? And we have a leaving group here, which I won't even mention because oftentimes we're not caring about that. So then in another scenario, right, we've got an E2 reaction. These are very similar reactions. Look at this. This nucleophile has got a lone pair of electrons and a negative charge. This base has a lone pair of electrons and a negative charge. So we've already talked about what the difference between these two are. Sometimes a nucleophile can act as a base, or a base can act as a nucleophile, right? So it goes beyond memorization. We sort of have to appreciate what's actually going on. And there's more, and that's what we're talking about right now. So the base, if it's acting as a base, it's going to abstract a proton, right? So the base abstracts the proton. At the same time, these bonding electrons become pi electrons, right? They're going to become pi electrons and go into a pi molecular orbital while the leaving group is leaving. And this is also concerted, right? This happens all at the same time. And so it's called E2 because the rate depends on both the base and the substrate. And the product of this reaction is right? And we have a double bond here now. And that is if this is atom 1 and this is atom, let's say X, just making stuff up here, right? 1, and X is going to be here, right? So that these guys both flip down and these guys both flip up, right? And it goes planar, okay? So these are the two products. This is an alkene. What is this? This is an alkene. And this, what this is depends on what the nucleophile is, right? If that's a hydroxyl, then this is an alcohol. If it's a halide, it's an alkyl halide, right? Okay, so this is an SN2 reaction and an E2 reaction. And let's now talk about the different factors that we need to be interested in here. So first of all, let me copy these things here. See, and go to the next slide. I don't want everything to come over. That's not useful, is it? Let's come here, and I want to erase some things. I don't want to talk about that. I don't want to talk about that. I want to clean this up a little bit so we can talk. Let's get rid of that. Let's get rid of that. Let's get rid of that. Boom, 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 boom. Just important to keep this story clean, right? So it makes it as easy for your eyes as possible to appreciate what's going on. This is what I would do if I was in a classroom, right? I would just erase, right? I'd go to the board and erase everything. I don't have a super command on my technology here, so that will take the time for that. All right, now we got that. Let's look at these. So what are the 4 factors that we need to consider here? And this is important for our future conversation, okay? Factors to consider. I've said all of them as we've gone along in our videos, okay? But it's easy to lose the trees for the forest. So let's look at them. The first thing we need to consider is the nucleophile or the base, okay? I say the first thing. If it's concerted reaction, then these sort of all things go together, right? That's the nucleophile or the base, okay? The next thing to consider is the substrate. right? And that's the substrate right here. So is the substrate, for example, is there a beta hydrogen? If there's not a beta, that is a hydrogen beta to the alkyl halide, right? Or to that carbon here. This is the alpha carbon, here's the beta carbon. And so this would be a beta hydrogen. If there's no beta hydrogen, it can't do an elimination, right? So that's sort of different things we need to think about with respect to the substrate. Now, the next thing we need to consider is the leaving group, right? We need to get a leaving group, something that has the ability to pull the electrons off and go off on its own. And the fourth thing to consider is the easiest thing to forget, and that is the solvent. Because I didn't draw a picture of the solvent up here at all, right? But in a previous conversation, I said to you, well, a nucleophile, if it's got a protic solvent around it, that is, let's say, water, okay, something with ionizable hydrogens, then this is like, can you see I'm drawing water molecules all around this nucleophile. That blocks the nucleophile, make a hydration shell around that, and makes it so it's not as easy to get in there, right? So we've talked about that. It's going to require some practice. And the difficult thing about the solvent is we oftentimes don't draw the solvent. We probably will put the solvent here, like H2O, put it under the reaction arrow to let you know it's there. But that it's there is going to be important for you to remember, okay? So we're going to be talking about the nucleophile of the base, the substrate, the leaving group, and the solvent. Those are the four categories of things that we need to consider when we're talking about substitution reactions and elimination reactions.